हमको कुछ अनम्यूट करेंगे तो
अनम्यूट किया हमें okay. Good morning everyone. Welcome to NPL and CSIR for battery coin experiment. So this is an event jointly done by CSIR and Hrdg, Royal Society of Chemistry, where we are promoting science in temperament to the students through different hands-on experiments and experience in this place. Okay. So as you can see, this event is being done simultaneously at 37, around 25 different labs in India, CSIR sister labs, and all are doing these experiments at the same time. Okay, so today this experiment is basically battery. You will be making battery out of coins and vinegar and very easy material that you use at your home. Okay, so battery. Anybody can you tell me what is battery? What is cell? Right. So yeah. Very good. So storing energy is the key here. Okay. So a battery is a material or a device or a packet where you store energy in form of chemical energy. Okay. So battery we use very extensively all around us, like in your cell phone, in your expensive batteries, your torches, everywhere batteries are there, and we have been using it for very long, right? You can see it all around. But this is one of the key elements which is required in the future in a very big way. Does anybody know about it? Power plant is for what? Power plant generates power. Electric vehicles. Okay, why electric vehicles are important? Because yes. So environment friendly, because we run them on batteries. Okay, and running them on batteries saves fossil fuel because why? Because fossil fuels are limited. No, but how do we charge batteries? Because we have to generate power. Power is being generated through we burn coal to generate steam and generate power, right? But we also do renewables, right? The wind power and solar power and nuclear also kind of, okay, and hydropower also. So if we store that energy, when that is in excess in the batteries, then we don't need to burn fossil fuels, and those batteries can be used for to run all our things day and night. Okay, so battery research is a huge thing. You know, Tesla is making wonderful batteries. Okay, they are going to transform a lot of things. So what is battery? That is the fundamental question we are going to answer, and we are trying to understand the functioning of the battery through your experiment today. Okay, so battery is just a few layers of material, some chemicals, some electron transfer, some chemical reactions is happening, and it is generating electricity. Okay, so some reaction is happening. As you know, you're from variety of classes, I guess, like 12th class, 9th class also. There's some students are from 9th. Who are from 9th? Okay, only one. Okay, but he is smart kid. He knows that on the electrode, on the battery, there reactions are happening, right? And whenever reactions are happening, electrons are coming in or coming out. Okay, those electrons are being used to generate electricity. That is electricity, and that is lighting the LED. So what you'll be doing is you'll be having a coin, 2 rupee coin. You will have a cardboard piece dipped in some kind of electrolyte. So you have different 4 kinds of electrolytes. Okay, one is very simple vinegar that we use at home, NaCl salt solution, simple salt solution, and 2 are H2SO4, which is an acid, and 1 is NaOH, which is the base. So while doing this experiment, please pay attention in handling H2SO4 and NaOH, because they can burn you. H2SO4. Okay, so be very careful. Use tweezers, wear your gloves, and be very, very careful. Okay, don't spill. Okay, now we have plenty of your mentors here who will guide you how to do the experiment. There is a procedure also written over here. You can read them also, and they will guide you as well. Okay. So yeah. Yeah, so we'll initiate you guys with the help of, please initiate with the help of these people. Will help you initiate and then you can carry on. Okay. Great.
And this is very simple experiment, can be done at home also because we are using vinegar. So you can try out the variations also at school or home.
And at the end, if you need to do some experiment at home, we can give you some LEDs also. Okay. So each student at least one LED so that we can do it at home.
All other CSIR labs, can you please turn on the video so that we can see what is happening at your place? KVIT and my Deepak, Archie. Okay, Needy, SCRC, please turn on your video. Or what?
in Bhubaneswar or in Delhi or in Mumbai, instead of polluting locally in the busy street by using gasoline engine or diesel engine, we can use battery powered engine or battery powered vehicle, which will at least locally will not pollute at that point of use. So that is how we see the use of e-scooter, e-bike, or the electric mobility. The cars and buses are coming up worldwide as well as in India. Bhubaneswar recently introduced electric buses. Many other cities already introduced, and electric cars are also have come, and you must have seen some electric cars are running with a green plate, and that will reduce local pollution. And in long run, we will phase out use of coal, we will phase out use of gasoline and diesel, and we will only use solar and wind. With this, I welcome you once more, and please enjoy your stay here at IMMT for a short period of time, but enjoyable stay, because you are learning science through demonstration, and all of you have come with a demonstration, and we will be very happy to see you. And I wish all of you very best in future. Thank you.
गुड मॉर्निंग, मिस्टर बोल रहे हैं। आपको सुना लगा रहा तो लग नहीं रहा था, पता नहीं क्या नंबर आपको। एक्चुअली क्या है, दिल्ली से जो हमारी डीजी है, डायरेक्टर जनरल CSIR, उनका एक लेक्चर है 45 मिनट का, और रॉयल सोसाइटी ऑफ केमिस्ट्री है ना, USA की, उसके साथ है ये सब का। ये तो बच्चों के जो 11th क्लास के बच्चे हों या 12th के जो केमिस्ट्री बैकग्राउंड को, तो जो लिंक मैंने दिया, लाइव लिंक आप कर सकती हैं। जैसे कोई आपके क्लासरूम में ये 10:45 शुरू हो गया है, वैसे बच्चे अपना डिमॉन्स्ट्रेशन कर रहे हैं, देख रहे हैं, है ना। तो 10:45 से जी लाइट नहीं, अच्छा। हाँ, यदि आते हैं तो बच्चे उसमें देखेंगे, क्योंकि बहुत ही इंस्पायरेशनल है। और जो डायरेक्टर जनरल हमारी जो है मैडम है, वो बहुत ही बैटरी में तो बहुत ही अच्छा उनका रिनाउंड है, रिसर्च है। तो जी जी, मैंने वो सब आपको भेज दिया था। जी जी, ओके।
are like this event may CSR head and she is secretary of government of India also. DG CSR, DG जो है हमारे director general, she is also coming to meet you guys, and you guys doing experiments, and there will be Royal Society of Chemistry delegates also. They are also coming. So you have to explain what you have done. Okay.
Yeah. পঞ্চাশটা কিন্তু কিছুমানতে 100 প্ৰত্যেক কিলো বেচা নহয় এই অংশগ্ৰহণ কি ৰক্তফলক কোৱাচোন ব্লক কৰি আছে বুলি অৱশ্যে
তুমি ক্যামেরা ভিউ ব্লক করে সার্ভার করে Essa começou a ligar tudo no telefone. Essa aqui também. Antona.
Fine. I think that's a good arrangement. Yeah. They can also get motivated by
Like a regular class.
One because we are like
Are the students going to come from the lab?
Now, our team will welcome all the dignitaries with a bouquet of flowers. You give it to him. Give it to him. Now, I would like to request Director CSIR and Professor Venugopal Achanta for the welcome address.
Good morning, everyone. So we have the privilege of having our DG, Dr. Kalai Selvi, for the first time on campus. And this is a good occasion. Thanks to Dr. Gita and the Jigyasa team for bringing her here. Uh, and the RSC team. Dr. Paul Lewis and everyone here, who made this happen. So Jigyasa is one activity where we continuously engage, the CSIR labs continuously engage with the local schools. We also at NPL in the NCR region, we have about 170 schools whom we regularly cater to and engage with. We have our open day, the science day, then we have the foundation day. So there are lots of occasions we interact with the children and we organize various events for them, starting with the quizzes and essay writing and all these things. In addition, we recently started 2 activities which are related to our founding director, Dr. K.S. Krishnan, on his birth and death anniversaries. So we organize events for the local schools. Right. So this is a way we are engaging ourselves. Our labs are open, so people do come for their projects, and enthusiastic kids are always encouraged to come and participate in our activities. Right. So because we are at NPL, many of you first time. So NPL is the National Physical Laboratory. So we wear 3 hats. We do basic R&D, being the only physics lab in CSR system. And we are also mandated by the Parliament of India to be the National Metrology Institute of the country. So we maintain, we set up, maintain and disseminate standards for the quality infrastructure within the country. And the third hat is being the part of the CSR system. We also take industrial projects and cater to final solutions for the industry. So I welcome on behalf of NPL family and all the enthusiastic kids whom we met. There are quite a few. I mean, what we saw is only a small fraction. There are majority of them are online today at our sister labs across the country. So I welcome you all, and we look forward to the MoU. Thank you very much.
Thank you, sir, for your kind words. Now, I would like to invite Dr. Gita Reisem, Head of CSIR HRDG, for the opening remarks.
Good morning, and respected DG CSI, Dr. Kalai Selvi, Dr. Achanta Venugopal, Director NPL, Dr. Paul Lewis, and other colleagues from RSC and Jigyasa team. It's really nice to be here, and as Dr. Venugopal said, this is also the first event for DG CSI as for the Jigyasa event. And even earlier, I had interacted with her when she gave a lecture in Delhi College. I don't know whether she remembers. In Delhi, on Women's Day, she joined online and gave a talk. Even then, I remember she was so passionate about her talk and she explained so beautifully. So I thought when we are doing Jigyasa today, why not have DGCSIR speak about battery technology. And as you know, today we are also doing this coin battery experiment, and Dr. Kalai Selvi is an expert in batteries and lithium batteries and sodium batteries. So I think it's a great amalgamation of the interests of CSIR and also taking it to the students. And as most of you have seen in the lab, students are very excited, and the excitement because they can actually do the experiment rather than just reading about it. So Jigyasa has been striving to do this, I think, for the last few years, to bring in the excitement for science among school students. And just to give a brief history, it started in 2017. Yeah, I have some slides. It's okay, leave it at that. Yeah. So in 2017, Jigyasa started with an MoU by the then DG CSIR and with Kendriya Vidyalaya Sangathan. So that was the first formal MoU. And after that, of course, we have done many more MoUs and have gone forward. So this was again I'll just give you 2 minutes, not long. So this MoU was to target students for Scientists Connect and develop scientific temper. And it's also important to train the teachers as well, not just the students. And there are different models. You can have residential programs, hands-on lab experiments like what we saw today, and tinkering labs. So it was launched in 6 July 2017. And there are various engagement models, like it could be scientists going to the labs, the students coming to the lab, vice versa, teachers workshop, so on and so forth. And the achievements which I would just like to tell is all the 37 laboratories of CSIR are very active in Jigyasa. And in fact, today you could see that almost 2,000 students across the country are participating in this experiment. This is really the strength of CSIR, harnessing it and taking the message forward. And so far, about more than 4.5 lakh students have benefited in this program in various ways. And even during COVID, we did not stop. So we had webinars and online quizzes. So that even COVID did not stop us. And as I said, we have a lot of collaboration partners because India is a huge country. CSIR can only do so much. We need partnerships. And we have really not stopped. We have worked with Kendriya Vidyalaya, Navodaya Vidyalaya, Niti Aayog. We have adopted 295 schools of Atal tinkering labs. Recently, we signed an MoU with Karnataka State Association, SNT, because again, India is a diverse country. We want to do in regional languages. So they are going to do Kannada content of our Jigyasa virtual lab. And very recently, we did an MoU with Bulandshahr Local District Administration, actually to go into the deep into the interiors and, take this message to the science schools. And IIT Bombay is our partner because they developed the virtual lab. Now, what is the concept of virtual lab? It came up when Honorable Minister, Honorable Prime Minister, when he took the society meeting in 2000, we presented about Jigyasa and he said it's a good program, but how can remote people in the remote parts of the country access this? Not everybody can come to the lab. So he said, can you have something like a virtual thing where people can actually see what it feels like to be in a lab and learn something about it. So that was the inspiration for this virtual lab. And we are glad that Honorable Minister Dr. Jitendra Singh launched it last year, 22nd November 2021. And you can see this is the website. So anybody can just log in and it's free. And you have games and we have Indian scientists. We talk about no role models for Indian scientists. Here we have our own Indian scientists, comics, all in a fun way so that people can really enjoy, not in a boring and tedious way. So there are also simulations, games. there's antimicrobial resistance, for example. But this is just the beginning. So we have 16 labs have participated in this virtual lab so far with 143 contents. Again, this is an ongoing effort. And most importantly, we have recently launched an Indian Sign Language also, because some of the people are disabled. So for them also Indian Sign Language, this CSR Rimtech is actually taking care of that. And we have more in pipeline. So I request all of you to spread this message also, because the more people it reaches, there is a benefit. And as I said, we recently did an MoU with Bulandshahr. We also tied up with National Council for Science Museums, because there also a lot of students come. So can we partner with them? And recently, as a part of Azadi Ka Amrit Mahotsav, we did this Jigyasa Vigyan Mahotsav, which was also done through this Jigyasa virtual lab portal. And in fact, the prizes were given by the Honorable Minister. More than 30,000 entries, 3,000 submissions were received, and it was a very engaging activity. So what is the roadmap for us? As I said, develop contents in regional and vernacular languages. And of course, sign language is another thing. And we are trying to do more and more MoUs with the state councils and promote innovation. And also, we also want to go international, because apart from that, so I think RSC is one of those in that direction, that our students also have exposure internationally. And so coming to the today's MoU, and before I go to the MoU, so we are looking at citizen science also. In fact, we are in talks with UP government. They are interested in doing citizen science initiatives and industrial linkages, camps, corporate social responsibility funding, and not only funding, even, industry related things which students can be exposed to. Innovation program, we are talking to Niti Aayog on innovation fellowships, which we had a meeting here again at NPL, and international linkages. And today we enter into partnership with Royal Society of Chemistry. I thank the Royal Society of Chemistry taking this initiative, and we look forward to the collaboration. And as I said, we had the global battery experiment, and then we'll have a DGCSIR talk about the future of battery technology. And I would like to thank Dr. Ajit, who has always been very helpful, and he makes us feel at home at NPL and offers as always. Thank you.
Thank you, ma'am, for your valuable thoughts. Now, proceeding with the event, the respective dignitaries from CSIR and RSC will sign the MoU.
You sell it. I think next. We cannot support this. No, we need a back support.
Thank you very much.
Thank you very much.
Now, I would like to welcome Dr. Paul Lewis, COO from Royal Society of Chemistry, to address everyone.
Very good morning to everybody. Namaste. First of all, thank you to Professor Akanta and the National Physical Laboratory for welcoming us all here today, and also to Dr. Reisem for those very warm opening remarks. Thank you. My name is Mr. Paul Lewis, and I'm the Chief Operating Officer of the Royal Society of Chemistry. It's my great pleasure to be here to celebrate our partnership with the Council of Scientific and Industrial Research. This is not my first visit to India, or indeed Delhi for that matter, and I must say I'm very glad to be back amongst friends after the travel restrictions over the last few years. And we are particularly honoured to be joined today by Dr. Kayla Selvey, the Director General of the CSIR. Very nice to meet you. Thank you for your warm hospitality. Thank you. The Government of India has an impressive vision for sustainable and inclusive scientific research and innovation, and the CSIR is playing a key part in delivering that vision. It is leading the way in applying chemistry to some of the most pressing problems that we face, from developing affordable medical equipment to the early detection of Alzheimer's disease. Its commitment to science with a global impact and to technological innovation or inclusive development make it a very valued partner for the RSC. For those of you who are not familiar with us, the Royal Society of Chemistry is a learned society and a global chemistry community with more than 50,000 members in over 100 countries. Our purpose is to help the chemical science community to make the world a better place. And the CSIR is closely aligned with that very same purpose. We are very proud of our existing collaborations with the Council and with the Government of India more widely, and we are keen to explore further opportunities to work together. As a global powerhouse of research and innovation, India is vital to the future of the chemical sciences, just as the chemical sciences are vital to the future of India. The RSC has been working with the chemistry community here for more than 75 years, and we are fortunate to have close links with leading scientists and organisations across the country. So I'd like to briefly highlight some of our wider initiatives before focusing on our plans with the CSIR. First, we are collaborating with the Department of Science and Technology, the Government of India, and others on the Inspiring India in Research, Innovation and STEM Education Initiative. This is better known as iRise, a programme that brings together industry and academic leaders to foster a thriving ecosystem for STEM education, research and innovation in India. The CSIR is another key collaborator in this initiative. Its National Chemical Laboratory is partnering with Durham University and Vitae to train PhD scholars as part of the iRise Early Career Research Programme. iRise is a fantastic opportunity to turbocharge scientific development in India, and I will be very excited to see the outcomes in the coming months and years. We are also supporting the UK-India Innovation and Sustainability Chemistry Consortium, which was set up last year by a group of scientists to address global sustainability challenges. It uses a virtual reality VR platform to enable researchers to work together more easily, and it's already delivering results. Over the past 18 months, consortium members have identified up to 6 joint research projects that they are actively pursuing. The energy and enthusiasm for scientific collaboration between our two countries is truly wonderful to see. As well as promoting collaboration, we want to enhance diversity because we need different perspectives to solve complex problems. We are particularly keen to support women to pursue chemistry careers and to dismantle the barriers that women scientists still face in many countries, including here in India and, of course, in the UK. Fortunately, things are changing, and as the first woman to head the CSIR, Dr. Kayla Selvey is a fantastic example of female leadership in action. But we also know that things are not changing fast enough. We are working with the Chemical Research Society of India, along with other partners, to highlight and address some of the challenges in India. And together, we plan to publish a report on gender diversity in India, which will set out a roadmap for empowering women, particularly in chemistry. Most important of all, we want to nurture the next generation of chemical scientists, and this is a key focus for our partnership with CSIR. Today's school children are tomorrow's scientists, and we must give them every opportunity to succeed. This is more critical than ever following the pandemic, which has disrupted the education of millions of children around the world. So we will partner with the CSIR to inspire and support young chemistry students and researchers across India through the fantastic Jigyasa outreach programme. And we have already identified 3 excellent opportunities for us to work together. Firstly, we will expand the RSC's Yusuf Hamid Inspirational Science Initiative, which we've been running now in India for several years. This includes our teacher training programme, which equips teachers with proven techniques to engage students with science. Over the last 7 years, we have trained more than 40,000 teachers across India, and our partnership with the CSIR will enable us to train even more. It will also enable us to expand the reach of our chemistry camps and other parts of the Inspirational Science Initiative. These residential camps give outstanding students from government-funded schools a taster of life at a leading laboratory to inspire them to pursue a career in chemistry. As well as helping young people develop new skills, we want to fire up their imaginations. Every year, the RSC runs the Global Experiment so that children around the world can experience the thrill of scientific discovery firsthand. And the focus this year is on sustainability. We have designed activities for students at every age to explore the science behind batteries and why they are such an important part of our energy future. And I've had the chance this morning to see a group of young people demonstrate the experiment and to see their enthusiasm. Well, it was absolutely infectious. It was one of the highlights of my trip. We are working with the CSIR and its network of 37 laboratories to maximise the impact of the global experiment. I can see out of the corner of my eye these students doing the experiment at the moment in some of those laboratories. Together, we will enable thousands more students across the country to try out this fun, practical science activity for themselves. And our hope is that some of these students will be inspired to pursue a future in science, future in chemistry. So finally, whilst the pandemic has brought many challenges, it's also highlighted new opportunities for education, particularly with the move to online teaching and learning. The CSIR Jigyasa programme will soon be launching a range of online learning initiatives with the potential to dramatically expand the impact of its outreach programme. The CSIR is going to share the RSC's learning resources through this platform, helping us to reach many more students and teachers around India. We are excited to continue to develop these kinds of smart collaborations with you in the coming years. By harnessing our complementary strengths, our 2 organisations can have a far bigger impact than we can alone. So, on behalf of the Royal Society of Chemistry, thank you so much to Dr. Selvi, to Professor Sharma, Dr. Reisem, Dr. Csir, all of the coordinators we've seen working so hard in those laboratories today with the Jigyasa programme, and to the whole team here at CSIR for the opportunity to deepen our partnership still further. So we look forward to finding new ways for the RSC and the CSIR to work together to strengthen the chemical sciences community in India. Thank you again.
Thank you, sir, for sharing your valuable thoughts. Now, I consider it a great honor to welcome the first female Director General of CSIR, Dr. N. Kalai Selvi, to deliver a Jigyasa Popular Science lecture on the topic Insights into the Future of Battery Technology.
Take time to know, no problem. Okay. Pleasant morning to every one of you. I take this opportunity to say thanks to maybe the Director NPL, Dr. Gita, and the RSC fraternity. Because I think you made my day in NPL through this particular program. As soon as I took charge as the DG, I really did not find time to visit NPL for the sake of NPL itself. But I think now I have the backdoor entry. But it's very great, and I'm really excited because now it's a double bonanza for me. I'm able to see my own colleagues here and my next level leaders, next generation leaders, those who are sitting on the top also. So this is how I'm getting a double time excitement today. And thanks for creating this particular opportunity. So more than any one of you, I'm really happy for 2-3 reasons. I think mostly students may also be knowing, and most of the scientists, those who are here, will also be realizing that today is a very, very special day. Can any one of you tell me that today is the birthday of Michael Faraday? 22nd September is the birthday of Michael Faraday, the great scientist. I do not know, knowingly or unknowingly, you have arranged this particular program for Jigyasa. And that particular program, also the focal theme is making all the students are trying their level best here to come up with a kind of a coin battery or coin cell, which is very much close to the heart of Faraday again. And they have called one electrochemist as a person to talk. And they have asked me to talk about the maybe fate or insight or future of the battery in the coming days. I think it's a great, great coincidence that on the birthday of the great scientist Faraday, I'm standing here in the National Physical Laboratory because he is known for physical sciences. So in the National Physical Laboratory, I think it's a great, great coincidence. Whether it is man-made or God-made or nature-made, I don't know. But it's a great coincidence. So that way, I think today is a very, very special day to all of us and especially to me. So taking this opportunity, I wish to place on record my sincere thanks and great appreciations to RSC. Because for every scientific fraternity, I'll come to the lecture in 2-3 minutes, okay? So because my own friends are sitting here. So for every scientific fraternity, publication is a great, great arm through which we can really touch upon our own friends as well as the upcoming leaders also. That gives us a lot of visibility, that gives us a lot of new freedom also, and that gives you a kind of a pathway by means of which you can just tell the entire world that who you are. So that way, when you just see the publication list, yes, we also have some kind of a priority. And of course, without any hesitation, everybody will have their topmost priority to RSC publications. So that way, you have also taken up your special efforts, the RSC family, to strengthen your tie-ups with the next generation leaders who are none other than students, and you have taken up Jigyasa as one kind of a content to sign an MoU. So that is really giving me a lot of additional pleasure because we are now living in an era, friends, both the kind of my own age group and the upcoming leaders, please start believing that this century is the century of India. Last century was not the century of India, but this century is the century of India and for India. So whatever best that we are going to perform in this century, that is where this country is going to be identified in the global arena. So we all should now gear up in a particular momentum, and we are especially blessed by the government of India also, because after we started celebrating this 75 years of independence, now we have extended it to the 100 years. We are now targeting 2047. Country is coming up with the National Vision 2047, and they have realized, country has realized, the leadership has realized that this particular vision could be achieved only by means of science and technology. So more than in the past, especially in the recent years, countries started celebrating science. Countries started celebrating science in women. Countries started celebrating science in all levels, and country still believes science with students, that is very, very essential in the coming days. So I think this is a golden opportunity for each and every one of you, those who are in this particular science and technology related area. So we have to encash this particular opportunity, because the topmost leadership, both in science as well as in the country, have given a thought that this century could be really made as a remarkable century only through science and technology. Therefore, we, other than those who are sitting here as scientists, apart from doing science, it becomes our utmost and bound duty to ensure that we have to really create, nurture, strengthen, direct and guide our own scientific heirs who are all sitting there. So we are having legal heirs at the family, so they are all our scientific heirs. So we have to really set them a role model. We have to just set them a kind of a good lab practices, good scientific practices, and we should really make them understand that the country is having a lot of expectations on them. So when the country is having a lot of expectations on them, who is there to guide them? It is none other than we, the scientific fraternity, who are sitting here. So friends from NPL, please accept my deep appreciations and congratulations that I'm telling from the bottom of my heart to each and every one of you for all the kind of legacy that has been already produced by this laboratory, and with what kind of current activities that are going on as on date in NPL. And I'm congratulating you in advance that because CSR and myself especially, we strongly believe that NPL will definitely go to greater heights, especially under the dynamic leadership of your director. Gopal is one good example of leadership. So he is taking all of you in one team. So I think with his dynamic leadership, my expectation on NPL is going high and high. And I know definitely you will not disappoint me even for a bit. So with this kind of a hope, I think now I wish to touch upon my upcoming leaders. So when Dr. Gita told me that I have to give one talk for Jigyasa students, I was thinking that I just asked her who are my audience. She said 10th class and 10th to 12th class. So I thought that my PPT should be prepared in such a way that should reach the students. Then suddenly I was given some kind of a sensitization that NPL stuff will also be there. So I think the slides will be partly satisfying them, partly satisfying you also. So in a way, kindly apologize me because I'm not able to do justice completely to you as well as to them also. It's a mix of all. So now let us just go ahead with the insights of battery, the future of battery technology. So as all of you know, especially my young friends, I do not know how many of you are aware that CSIR is a big family. Country is also a big country. CSIR is also a big family. So this big family consists of 37 national labs. All the 37 national labs are spread across this country in 26 cities. So I have mentioned what are the cities in which you can find out CSIR labs. And we are offering UG courses, PG courses, and PhD courses also through the CSIR labs. So today I already told you, being the birthday of Faraday, so I think we have to talk about something on energy and something on battery also. So if you just take energy, today the mantra or the slogan is green mobility enablement. So that could be achieved by 2-3 ways. One is fuel cells. All of you know that fuel cells are nothing but green hydrogen driven fuel cells for e-mobility. Next one is batteries. So the batteries will now come up with, they will create a new era called EV era, electric vehicle era. And of course, supercapacitors are also coming up parallelly because wherever batteries cannot give you the kind of a power that is required, especially when you just travel to a mountain, you need high power rather than more energy, you need a peak power. So at that time, the supercapacitors will be of your help. Normally in life, people used to say that if you want to be a good, successful person, normally self-confidence is required. So you will just run your life with self-confidence. Whenever you just slightly get some kind of a dejected mode, or whenever you feel that some kind of a low profile, at that time people say that it is the other confidence. When self-confidence is going to the low profile, you should think that the nature will give you the other confidence, or you would say that the divine confidence will take you to the next level. Similarly, batteries will take some amount of energy, they will take you. And whenever you need extra energy, the supercapacitor will give you the additional peak power. So that we call it as hybrid electric vehicle technology. But today I'll be able to just share with you what and all one can do and what and all this country can expect as far as batteries are concerned. So this slide, I think all of you are totally aware because all students starting from maybe class 3 or class 5 to up to class 12, everybody were aware of the fact what global warming is because we are experiencing it every day. And you know what is pollution and pollution related problems also. And apart from that, I think fast changing consumer market trends also, you know better than anybody. Because in the morning also I was telling to one of my friends, once upon a time technology means we said that it should be a rugged technology. But the definition of technology is also these days getting redefined. Because we don't want any technology to be a long living technology. For example, especially with the mobile phone, If at all you are using the mobile phone continuously for 3 years, then your age is 50 plus. Because everybody, they now want to have a change in technology. How many of you want to use the same washing machine for more than 10 years? No, nobody is interested. So these terms called guarantee, warranty, I think in future all these technologies will disappear also. Because all of us, we want to just experience the new thing. I want to know what it is. I want to experience what it is. So that's why, technologies are also becoming short-lived. In that way, day to day, expectation from the society, expectation from the market, especially from the consumer side, it is changing. So with the fast changing consumer needs of the market or the society, I think this is high time that all of us should think about batteries. So among the batteries, I think there are a number of batteries, primary batteries and secondary batteries. Primary batteries are like, I should not use the word plastic because now we are using and throwing it, we should not be. Primary batteries are use and throw batteries. And secondary batteries are the ones that could be recharged a number of times. As many times as you want, you can recharge and you can use them. So today we are going to talk about only the secondary battery. Even in secondary battery, once upon a time, people were using lead acid battery. So I do not know how many of you would have experienced, but those who are sitting here, we have experienced when we were traveling by common mobile bus and all. Under the seats, they used to keep a big bang of battery. So that battery is the lead acid battery. So it is so big, so huge, and it is weighing huge, and therefore community did not want this kind of a heavy things and all. So we started moving to alternate things, and its voltage was also very less. So the next generation was on nickel cadmium. So we were happy with nickel cadmium for quite some time, but this cadmium, no, it is having one major issue that cadmium's memory power is so strong. As a student, you will be thinking that memory power is good. Yeah, it is good for human beings, but not for metals like cadmium. I'll tell you why. For example, if you are having a mobile phone which is powered by nickel cadmium battery, and if you're charging it here, it is supposed to be charged for 1 hour. But after half an hour, you have to now run to your school. Therefore, you are just removing the charging, meaning is you are not allowing your battery to charge further. So if it is a nickel cadmium battery, this cadmium metal will just make it in its memory that, okay, 80% charge is sufficient. So that will go to its memory that this particular system, this particular phone, it is enough if it is charged up to 80%. So this we call it as the undesirable memory effect of cadmium. Meaning is next day if you want to charge it for 100%, it will not accept. So this is called the memory effect of cadmium. Therefore, that scientists, we realized it. Then we moved on to nickel metal hydride battery. Yeah, we were very happy. But again, here the voltage was less. But now we are living in an era where we want maybe size 0, slim, thin, sleek, thin, flexible. All these things they are becoming the order of the day. Therefore, people thought that I want which could be as thin as possible, as slim as possible, but as powerful as possible. So this is where lithium batteries are coming into picture. So one small lithium battery can give you even 3+ voltages. This is how lithium came into picture. So if you just today's market, there are two markets. One is consumer market, which I was talking about, where we want everything to be new. The other one is EV market. This is, I think, this is a need of the hour, because now we can't say that we will still go with the petrol, gasoline, and all these conventional fuel-driven buses only. It's not possible, because I think as responsible citizens, you will also be knowing what is COP21, what is COP22, what is COP26. Country has already promised that we will be able to reduce the carbon footprint in the coming days. That could be made possible only by means of EV batteries. So if you just take consumer market, today there are two strong candidates. One is lithium battery, the other one is sodium battery. And if you just take the other one, EV market, again, I think sodium batteries right at this point of time, I cannot vote for it. Whereas days are not so far off, even sodium batteries will also qualify themselves for their application in the EV system also. Right at this point of time, I'm talking about today's trend, current trend, especially in Indian trend. So it is lithium and some other battery, or lithium and supercapacitor. This we call it as hybrid. As all of you know now, all of you know what is a coin cell. So apart from coin cell, we have cylindrical cells, we have pouch cells and prismatic cells. So if you just ask me what is, I will just take only half a minute to tell you what are the different types of lithium battery. In the case of lithium battery, initially, I think all of you know that battery means one anode, one cathode, and an electrolyte. I was so thrilled to listen to all students. They were talking about electrolyte, effect of electrolyte, the power of electrolyte, strength of electrolyte, all these things they were talking about. So you need an anode and a cathode. So in the case of lithium, actually, initially people started using lithium as the anode. So we call it as rechargeable lithium battery. Later on, we realized that lithium is a very reactive metal. It started giving some kind of a dendritic issue, dissolution issue, and therefore they removed lithium with carbon. This is how lithium ion batteries came into picture. Next comes lithium polymer battery. In the case of lithium ion battery, the electrolyte is a non-aqueous liquid electrolyte. Meaning is whenever you are carrying a battery from one place to another place, there is every threat that you may come across some kind of a leakage due to the liquid electrolyte. So people started replacing the liquid electrolyte with the polymer electrolyte. This is how we got lithium polymer batteries. And the last one is lithium ion polymer battery, wherein your anode is also carbon, meaning is you won't come across any problem with respect to the dendritic issues of lithium, and your electrolyte is also a solid polymer. Therefore, the ultimate choice should be, the idealistic system should be lithium ion polymer battery, wherein you don't have any problem with respect to your anode and you are not worried about your electrolyte also. Now, this is about lithium battery. Now, you can say, that's why I told you very cautiously, every technology is short-lived these days, and we don't have any guarantee how long this lithium chemistry is going to be celebrated across the globe. Therefore, we have to now get ourselves geared up for the next generation technology. So this is where we, means the scientific community, we started thinking beyond lithium chemistry. What is it that beyond lithium? So there you can think about sodium ion battery, lithium sulfur, metal air, redox flow battery, and supercapacitors. And of course, hybrid, as I told you, you can combine one battery with another battery or a battery in the supercapacitor. So this is, what is it that, why should we really worry about EV market and lithium battery today? So COVID changed a lot of things in the country. It has created a new history, but then as far as India is concerned, the country is fully populated with the two-wheelers. So here post-COVID survey also says that India is one such country wherein EV market is only really having a lot of opportunities in the coming days. So we have to get ourselves prepared for that kind of need of this country. Now India is coming up with a number of lithium battery related producing facilities, either in the form of a prototype or in the form of a pilot plant or in the form of a commercial plant also. Number of initiatives are going on parallelly in the country in different places. It's a very good scenario. So, but for the sake of students, I will just spend half a minute to tell you what lithium battery is, how does it work. You can just try in your next experiment also. As I told you, one side you have anode, the other side you have cathode, in between you have the electrolyte. So like the way two players are sharing one ball. So here the ball is nothing but lithium ion. Lithium ion shuttles between the anode and the cathode, for which it is using electrolyte as a medium. So the other name of the battery is shuttlecock battery. The other name of the battery is rocking chair battery. Meaning is lithium ion is swinging between anode and cathode. The bottom line is nothing but lithium ion should be allowed to move from one electrode to other electrode, and it should be allowed to come reversibly also, so that you can use the battery for n number of times. So now I told you cathode is there, anode is there, electrolyte is there. Who is the big boss? That is a question now. Of the three, who is the strong one? Who is it's not muscle power, it is the real action, or who is the major contributor. In any battery, cathode is a major battery, especially with respect to lithium battery. And therefore, if you are able to do some magic, some improvement, some progress with respect to cathode of a battery, it is as good as you are improving the total chemistry of the battery. You can keep the remaining anode, electrolyte and all the same. If you are able to empower only the cathode, you are empowering the performance of a battery to a great extent. So that's why cathode is getting celebrated. And I will just tell you 3 types of cathodes are very, very popular. One is layered lithium cobalt oxide. Those who are having, I think everybody will be having mobile phone, because mobile phone is having one cathode, which is lithium cobalt oxide. Because I think school children also will be now having mobile phone. I think you are the real good users of mobile phone even than your elders. Because once upon a time only school said no mobile phones inside the school. COVID said school should be inside mobile phone. So this is how mobile phones became very, very popular. So now all of you are totally aware and you know better features of the mobile phones rather than your father or your elder brother or whosoever it may be. So this mobile phone is powered by a lithium battery wherein you should know the cathode material as on date is lithium cobalt oxide, the first one. Many times people say that when it was put in charge, it got fire. So that is called lack of safety upon overcharge. Lithium cobalt oxide, I'll tell you in simple words, it's a layered one, like I do not know the name of the sweet, we call it a son papdi. Same. Okay. So lithium cobalt oxide, whenever you look your battery hereafter, you should get reminded of son papdi and lithium cobalt oxide also. Because this lithium cobalt oxide, its structure is layer by layer structure. One layer and the other layer, we call it as a layered structure, and graphite is a good example. So one layer and the other layer, you have in between one space, which we call it as interstitial space. So this lithium, I already told, like two players are sharing one ball. Lithium is a moving ball. Lithium will go from one electrode to other electrode, where it will sit. So it will find a place in between these two layers. It will go and occupy the interstitial position so that at any point of time, it can come out. See, for example, if you want to attend a meeting, you are not sure whether the meeting is going to be interesting or not, which row you will take, you will not come to the first row. You will either go to the last row or somewhere in between. Meaning is at any time you can just go out also. So same way, lithium will also come. It will not have a perfect seating over any layer. It will choose an interstitial position so that at any point of time it can go out. So that is the beauty and that is the flexibility by means of which we are getting the rechargeability possible. So this lithium cobalt oxide is having a beautifully arranged layered structure by means of which it is allowing lithium to come and go. Therefore, why the hell it is catching fire? That will be the next question. This lithium cobalt oxide, its structure is arranged in such a way that its stacking is A, B, A, B. Lithium, cobalt, like that it is arranged. And if you are taking more than 50% of the cobalt, because I said that lithium is going here and lithium is coming here. Therefore, stability should be there. So when lithium is going inside, the structure will take a different shape. And when it is coming out also, it will take a different shape. So this lithium cobalt oxide, its structure can allow only 50% of the lithium to be taken. For example, if you are taking more amount of lithium from lithium cobalt oxide, slowly one layer will slip over the other. We call it as the slipping or the cascading effect with respect to lithium cobalt oxide. So when you are taking more lithium, meaning is overcharging, you are trying to take more amount of lithium from the system. So the layers will start collapsing. So this is where you will come across one process called thermal runaway. So that will really create some amount of a heat. That is why your battery is catching fire. Therefore, when you are putting your mobile phone for charging, similarly, those who are using, I think everybody is using laptop. Laptop also, when you charge it to 100%, don't leave it as such as unused. Because again, in lithium battery, which is used in laptop, it is also having lithium cobalt oxide. I'll give you one good example. I'm giving you all food, then I'm closing all the doors of the room, and I'm telling you should not go anywhere. You should not do anything. You should not talk to each other. What will you do? 5 minutes you will listen to me. 10 minutes you will be just looking around your friends. Then 15 minutes you will start kicking the chairs. Because now you have full energy. So when somebody is fully energized, and when the same person is not allowed to do any work, he or she will start doing undesirable work. Same thing lithium cobalt oxide will do. Therefore, when you are leaving your laptop, close it when it is having 80% of charge or 90%. Don't leave it at 100%. So meaning is you are reducing the life of a battery. So this is the these are few precautions I'm telling you because today we are dealing with lithium cobalt oxide. But of course other cathodes like lithium manganese oxide, and I'm telling you like the way I'm telling you are the next generation. Even for battery chemistry, who is the next generation cathode? It is the last one, that is LiFePO4. You can ask me why. Now I told you lithium cobalt oxide will allow you to take only maximum of 60% of lithium. When more than 60% of the lithium is taken, that will start creating you problem. Whereas lithium ion phosphate, the last category, LiFePO4, that will not give you any kind of a problem because it has one phosphate. That particular structure, polyanionic structure, this structure will give you a kind of a safety with respect to thermal runaway. Meaning is, I call it as a safe cathode. So next generation cathode is a safe cathode, which is LiFePO4. So these are the different methods by means of which you can prepare lithium cobalt oxide. As students, you can ask, can I do? Yes, you can do, but not all the methods. I think everybody is now fully aware of microwave. If you really want to synthesize some kind of a lithium battery related cathode material, you can try in your school lab. What you need maximum is one microwave, which is the fourth one I have given. So you can just take some precursor of lithium, some precursor of cobalt. Example, I will tell you, maybe some lithium oxalate, maybe some cobalt oxalate in the appropriate ratio. Then you just cook it in the microwave oven, you will get lithium cobalt oxide. Then you can say that, ma'am, that much is the thing. Then why the hell India is already have spent 4 decades, 5 decades, still you are not successful in lithium chemistry. Story doesn't get ended over there. First, you have to identify what are all the raw materials which are qualified. That is number one. And second thing, you have to prepare it with the required purity. It should have the morphology. It should have the porosity. It should have particular conductivity. So many things. A human means we should have 2 eyes, 2 ears, 1 nose, 2 hands. You cannot say which one is more important. All are important, equally important. Only then you can say I'm fully functional. Similarly, for any cathode, to make it fully functional, you need many factors. So that is where you can do many tricks, many magics with a number of methods. So this is one method I'm just telling you. It is salt and gel. Salt stands for solution. You can dissolve the precursor in the form of and get a solution. Then you can just allow it to go as a gel. You can add some gelling agent also. For example, whenever we are taking soup at home, if the soup is very dilute, what mother will normally do? She will immediately add some corn flour so that it will immediately get some densification. So some gelling effect, then the soup becomes, okay, fine. Now child is happy, mother only knows it's a very simple secret. Same corn flour could be used as a gelling agent in lithium battery also. So this is how a solution can be made as a gel, by means of which you can reduce the time of heating. If you want to evaporate the entire solution and get a solid product, you have to wait for longer hours. On the other hand, you make it as a gel, then just heat it for a smaller time, you will get the same product. So this is how you have to apply different strategies and you can get any powder. Now the powder is ready. It is a cathode material. Now next question is, ma'am, how to go about? It's very simple. Take the powder, make it as a slurry and just coat it over the electrode. So that is called cathode. Cathode is not a powder, cathode is an electrode, it's a coated electrode. So you have to take, if it is a cathode, you have to take an aluminum foil over which you have to coat it. If it is an anode, you have to take a copper foil and you have to coat it. Of course, I told you anode is not lithium cobalt oxide, anode is carbon. Okay. But today we are not going to talk about anode. So you can ask me, madam, can I do it in my room or in my classroom or in my laboratory? No, it is not possible. This is where the fuzzy things, the delicacy. So lithium is a delicate darling because you cannot handle it so easily. At room temperature, you cannot play with it. You know, most of you know how to handle sodium. Where will you keep sodium? Kerosene. So, but lithium, don't put it in kerosene. So lithium is again much more stronger and it is very, very fast in reaction. And therefore its reactivity is so high that you cannot handle lithium at room temperature. You cannot keep lithium on your palm and you can show that this is lithium. No one can show that because it is highly reactive. It should be handled in an inert atmosphere. I think you may be knowing what are inert gases. Can you tell me inert gases? Argon? Not definition, example. Argon, helium, neon, krypton, xenon, great. So I think science is very good. So now you have to keep this lithium in a glove box which is filled with an inert gas which is argon gas. So argon filled glove box is the storage point where you can have this lithium. So only by handling, by using this argon filled glove box, you can go ahead with lithium. Sometime back I told you the next generation is not lithium cobalt oxide. It is going to be lithium ion phosphate. So this is what I told you. Phosphate is a polyanionic structure and therefore it will not catch fire even if it is overcharged. It's a rugged structure with lithium and without lithium. It is having a stable structure. I think its mental stability is so high. It can accommodate full amount of lithium, 100% lithium also. It can sacrifice 100% lithium also. I think it's a saint. So it is remaining unshakable. So that is the beauty of this LaFePO4. Therefore, you should know how to prepare LaFePO4 also. Very simple. Take some lithium related powder, iron powder, and for phosphate, you can take some ammonium phosphate. You can just grind and you can make it as a powder. Then you can just heat it. But here comes the major issue. Lithium cobalt oxide, you can use it as such, but lithium ion phosphate, I was going on telling, it's a big phosphate, it's a polyanion. This polyanion is reducing its conductivity and therefore it behaves like a semiconductor. But I told you initially itself, for a good cathode, its electronic conductivity should be very high, and therefore now you have to increase the conductivity, for which carbon will help you. Therefore, LiFePO4, always you should prepare it as a mix of LiFePO4 and carbon. So then this will look like, so LiFePO4 will be at the center, and you can just make some carbon clouds or carbon powdered coating over the surface, by means of which you can just prepare LiFePO4 and make it as a conducting, electronically conducting material, and you can make it as a successful cathode material. So then you can ask me, madam, you always want only spherical cathodes? Because I said morphology. So morphology is very important. Then you can ask me, only spherical morphology will give you the capacity? No, it is not so. You can go with the rod also. So whatever it may be the shape, whether it is a ball shape, round shape, sphere, or a rod, or a thin wire, whatever way you are preparing it, one condition for LiFePO4 is its surface should be completely covered by carbon, only then you can make it as conductor. So this I am giving you why, because many times in my own lab, my own research scholars will tell, ma'am, it's highly boring. All the time we are starting with a white raw material, and all the time we are ending with a black final product. This black and white combination I am fully fed up with. It looks like I am a 1940s kid, like I am not a 1940s kid. So for such students, you can say that they can play with colors. So this is one method called co-precipitation method and salt gel method, where you can really adjust the pH, and by way of adjusting the pH, two things you will get. You can get the gelation, as well as you can see some good colors also, so that you can make your maybe lab also very colorful. So this is one way of preparing. Another way of preparing this cathode material. As I already told you, ma'am, is it necessary that only carbon should be used as a coating material? It is not so. It is not so. If you feel that you can give other coating also, you can just go ahead with some metal oxide coating also. So depending upon the material that is getting coated over the surface of the major cathode, its performance will also increase. So this is another colorful reaction I just wanted to show you. So in this case, now you are getting a different kind of, this is a kind of a ladu kind of a thing. So here also you can get a different kinds of ladu, a completely filled ladu, as well as maybe inner sphere will be a hollow sphere ladu also you can prepare. So according to your requirement, you can prepare. So this is one interesting slide I'll tell you. So far I was telling, I give you a caution also. Cathode means lithium cobalt oxide, anode means carbon. Now I'm just giving you one good example. There is one material which can act both as a cathode and as an anode. Now, what is this new thing you are talking about? It's nothing but you can prepare one material, and this material will act as a cathode at a particular potential domain, and the same material could be made as an anode at another potential domain. Why? Because all these cathode materials, now only I'm coming to the theme of this cathode material. So what is the, I just told you lithium cobalt oxide. So what is the magic, or what is the basic behind this lithium cobalt oxide? It is nothing but any cathode should be lithiated transition metal oxide or phosphate. So lithium is needed, transition metal is needed. This side you can have oxide or phosphate. Why transition metals? I think you may be knowing transition metal, maybe first row transition, you may be aware of scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Am I right? D1 to D10. So first row transition. So transition metals are known as metals with variable valency. Meaning is one metal will be finding its stability in its +2 oxidation state, in its +3 oxidation state, in its +5 oxidation state also. This we call it as variable valency. Therefore, when lithium comes, this will go from 3 to 2. When lithium goes, it will get oxidized from 2 to 3. Meaning is it will somehow attain its stability at one oxidation state or the other. So here I have taken LVP, meaning is vanadium. Vanadium is a beautiful metal where it can stabilize itself in a minimum of 3 oxidation states. Vanadium in its 2+, vanadium in its 3+, vanadium in its 5+. Therefore, the smart student will prepare vanadium in its mid oxidation state, meaning is in its 3+. Therefore, you can make vanadium to go from 3+ to 2+. Therefore, you are allowing it to act as anode. If you are making vanadium to go from 3+ to 5+, you are allowing it to act as the cathode. That's all the magic is. Therefore, you have to prepare the material in its mid-oxidation state. You should allow it to undergo reduction as well as to oxidation, by means of which you are making the same material at two different potentials to act as anode and cathode. This we call it as dual electrode characteristics. This is something new to my young friends. So I told you, apart from lithium battery, next generation is sodium. Then I told you one more thing also. Days are not so far off. Sodium will also come up very fast. Very easily you can make the sodium chemistry to compare itself very well with the lithium chemistry. This is one good example I'm showing. Then lastly, I told you, so India is a country where you are not having only plains. It is not only the surface transport. Many times you have to go with a hillside transport also. Therefore, you need some kind of an additional power where you can have lithium and supercapacitor. So this is a three-wheeler. Some kind of trials are going on in CSIR labs also. So I think that's all with respect to all these things. This one photograph is one facility which is fully funded by CSIR facility. So this particular facility is able to cater to the country to the tune of making 1,000 cylindrical lithium ion cells per day as outputs. So this is the huge support of CSIR. I think with this, if at all I'm able to make some kind of an interest, create some kind of an interest of all these audience with 1 or 2 students, I think I consider that as the great success of lithium chemistry and Indian science and technology. Thank you, Anna.
Thank you, ma'am, for enlightening us all with your knowledge. Now, I would like to invite Mr. Ajit Sharma, Managing Director, the Royal Society of Chemistry, India, for the closing remarks of the event.
अपनी बात रखने से पहले मैं एक प्रश्न पूछना चाहता हूं कि किसी भी राष्ट्र के निर्माण के लिए सबसे जरूरी चीज क्या है? टू बिल्ड अ कैपेबल नेशन, what is the most significantly important thing? Anyone? Absolutely, and thank you. So first of all, let me really take this opportunity to thank. There are several hundreds of students who are connected through the online channel, as well as lovely kids sitting right in front of me. Thank you very much, because today is a day which will change the life of your future, in your future, forever. This is a small ignition that has taken place, and if you take this seriously, the entire course of your life will change for better. So thank you for attending this event, and thank you for giving your time and consideration. We really appreciate it. On the dais, we have Honorable Madam Director General, the Director of the campus, as well as Madam Dr. Gita, along with Paul Lewis. I really thank all of you to have taken time out of a busy schedule. Not one of you is in a position to spend a minute without compromising from your calendars. So on behalf of everyone, we really appreciate you, really thank you for this. My second the vote of thanks is for Sridhar and his team, and a gentleman who shares the same name that I do, I think Ajit, who was doing a good speech when I joined the experiment. He was really empowering the entire gang of students into high energy mode, from low energy mode to high energy mode. So thank you very much, because that's the fire which is required to ignite the young kids. You cannot do it slowly. You cannot do it in the wet atmosphere. Also, real thanks for Bhakti and Rajesh, who made this possible, who worked diligently on the background there are a lot of late night emails that I am kind of witness to, which went back and forth, back and forth. But eventually we came to a conclusion and we signed an MoU. So thank you very much, both of you. Really great work. And with this, I would like to conclude. Everyone, thanks for your time and attention. Namaskar. Jai Hind.
Thank you, sir, for your words. Lastly, I would like to invite Dr. Ajit Kumar on the stage for the vote of thanks.
Good afternoon, everyone. And I would like to, on the behalf of CSR NPL, I would like to thank all of you to be here. First of all, DG ma'am for gracing us on this occasion, and Dr. Gita ma'am and Dr. Paul Lewis and RSC team. And I would like to thank all the CSR headquarters and Jigyasa team for all the guidance and everything. I would like to thank our director for the support and all the NPL facility colleagues and Jigyasa team, and especially the students who helped us organize this event. And how can you forget all the students who have come here and made our day wonderful. We always welcome students on our campus and enjoy their presence. So I would also like to thank all the support staff. They have helped us wonderfully to organize this event successfully, be it auditorium, HLS, or stores and purchases, and everyone to help organize this thing. With this, I would like to thank and that's it. Thank you. Yes.
Thank you, sir, for your words. Every day holds the possibility of a miracle. So keep hoping for the best. And I thank you all for being such a wonderful audience. Thank you.